Hey, so I just wanted to talk about a powerful idea that I saw from somebody while I was studying econometrics. I'm doing a review right now, and it is probably the first time I've ever seen this. But essentially, what they did was they expressed the bias of the model. So we're always talking about bias and these neural network algorithms and the multi-factor regression, stuff like that. You reduce it just to your inputs. So your inputs have some sort of error in them, and we seek to reduce that error. And so the equations I have up here sort of tell you the relationship between that signal to noise ratio and your bias. So you can think of, in your simple linear regression equation, you think of the value of x that you have is, the real value of x plus some junk that other people added in or some sort of measurement error. This equation, so if you take that theoretical value of x and you put it over the theoretical value of that error, supposing we could measure how much error there was, or we could audit and go back and measure how much error there was. If you take the variance of the theoretical over the variance of the error, that gives us something in science that they call a signal to noise ratio. And also, you'll see that I've highlighted noise on this chart. So noise, or your residual, or whatever you want to call it, the epsilon, would have some sort of relationship that we need to express to the error, the measurement error. So if we define bias as the difference between your approximated beta and your actual out there in the clouds beta, the real value of beta, you can ultimately reduce that to the negative beta over 1 plus your signal to noise ratio. And if we run some calculations, you'll see that as your signal is stronger, your bias is lower. And as your error is higher, your bias is higher. So the reason why this is so powerful is because then you can plot it across, and it gives you sort of this curvature of the relationship between your signal to noise ratio and the bias of your model. So that's all I wanted to talk about.